Swayam Prabha. Digital India. Educated India.
So this is a representation of the global surface average temperature across the years. It has been recorded since 1817s till the recent 2020. And across the decades, we have accelerated climate change. Right? Climate change has already been there. It's a natural phenomenon. What we did is successfully accelerate it through our industrial revolution and interventions. Now, if this is possible through mankind, the philosophy is we need to take action to reverse this. And I took inspiration from this image to create this small icon at the top of the eye. And the company was named as Climate Action Before Day Zero. And what we do is we help students, professionals upskill themselves on green skills. And also I advise corporates on their product sustainability, corporate sustainability initiatives. So that's a quick introduction about the company. We are 7 months young, and before that I was a sustainability lead at Saint-Gobain, right? So that's a bit about me. More than 11 years of experience in sustainability, and I've worked across product building and corporate sustainability. I've also done some policy work at BIS and BE through industry bodies like CII and Glazing Society of India, etc. So, and I was responsible for launching India's first low carbon glass, which is 54% lesser global warming potential than any other lesser products during my time at Saint-Gobain, of course. Okay, I'll quickly skip this. So, what we do is advisory, as well as we have an academy called Climacto Academy. These are some of our clients. In the last 6 months, we have upskilled more than 300 people. Our target is around 30,000 people by 2030. So, we are at 1% of our target. So, as a guy who's there in ESG, who's been running behind KPIs, I have set my own KPIs as well. So, this is about it. Yeah, some more images. So, I'm not new to training, so you're in safe hands for the next 1 hour. Cool. So, today's plan, we will start with we already started with a quick introduction. I will try to cover the life cycle assessment from a building's perspective. And I will also try, once I cover the, I'll just brush up on the basics in that case, because many of you were not willing to raise your hands. So I'll quickly brush up on the basics of embodied carbon of a building. And I'll also cover some of the trends that are there that we observe in the industry when it comes to life cycle assessment intersecting with embodied carbon and ESG, right? So that's something we will do, and then we can have a quick short discussion on any queries. So this is going to be the flow. Okay, so we have a problem at our hand. The built environment is responsible for all of this. Like it is contributing to almost 40% of energy consumption. Water consumption more than 10% in India. We don't have a global number in place. How much exactly is coming from the built environment? Waste generated is almost 30 to 40%. Includes both during construction, which is the C&D waste, the construction and demolition waste, as well as the operational waste that we generate every day. The range is between 0.5 kg to a kg of waste per capita, right, per household. That's how much is the waste that we generate every day. And that accounts to almost 30 to 40% of the global waste that is being generated. And of course, the fourth point is the GHG emissions from this one industry is 30 to 40%. Right? So this is all that the impact that the industry is creating, this one particular sector is creating. So then what do we do? Do we not build at all? No more development? Is that the line of thought? Should the answer be degrowth? That's debatable. Like we can't take very strong positions on this, but what we need to do is balance, right? We need to grow at the same time, find a way to grow responsibly. That's what we need to start thinking about. And as a developing country, we have a vision for ourselves. By 2047, we need to become a developed country as a Vikshit Bharat. So to become a developed country, we can't stop making roads and stop making buildings. But what we can do is make them responsible and make them more sustainable. So the green building movement in India for the last 2.5 decades has been very active, and I've been there in that movement for almost 1.5 decades. And what we see is sustainable construction is possible, and it is a possible solution for what problem we have in hand. So the storyline till now is buildings are part of the problem, but I can show you how they can also be part of the solution, right? And there's a business angle to this as well. So there are so many rating systems. You see a few logos over there: the Indian Green Building Council, the Griha, the Well, the Edge, the US Green Building Council. All these rating systems are active in India, and there are a lot of business benefits. The total cost of operations can go down. If you're making your building green as a developer, they can get better ESG ratings. You could get better occupants. You get quicker environmental clearances. There are a bunch of benefits. And also, there is one more angle to it of saving the planet, where you can make a building which consumes lesser energy, lesser water, lesser weight than the lesser waste than the lot, right? So, okay, in green buildings there is another next layer of green buildings, which is a net zero energy building. A net zero energy building does not mean that it doesn't consume energy at all, right? It does consume energy. Let's say that a regular building consumes 100 kilowatt hours of electricity. I'm just saying for example. You take measures like the best efficient HVAC, the most efficient materials, and all of that you do and bring it down to say 20 kilowatt hours. So it's still not zero. For the remaining 20 kilowatt hours, you shift towards greener power, right? And then you do the math, it comes close to zero. So there is no, if someone claims that their building is an absolute zero building, then you'll have to raise your eyebrows. Like it might not be true. All that you could do is achieve net zero, where you do the math and it comes close to a zero, right? So even in a net zero building, there are going to be some residual emissions, right? So there is a carbon footprint in spite of it being a net zero energy building. And that is mostly the carbon emission that goes unaccounted at all, which is the embodied carbon emission. So now I introduce this new jargon to all of you. Embodied carbon is nothing but the carbon footprint that goes into making the building, which is the cement, the steel, the aluminum. All these raw materials get manufactured. Most of these materials are hard to abate, right? So cement, when you manufacture 1 kg of cement, can anyone tell me what is the carbon footprint? Yes, 0.8, and that can range from 0.8 to 1 kg, right, depending on the type of the raw materials that I used, and it can be brought down to as low as 0.4, 0.5 also if you add some other materials instead of limestone, right? So cement is that. Steel, any guess how much is the carbon footprint of 1 kg of steel? 2.5 kgs. If you have to get 1 kg of steel, you are going to emit 2.5 kgs. That's the Indian average. There are products, so in steel again you have primary steel and secondary steel. Primary steel is from the ore you get, you do mining, and then you melt it at a higher temperature, add other processes, and that's the primary steel. There's a secondary steel which is made mostly out of scrap, right? So that secondary steel can go as low as 0.6 kgs per kg, right? There are Indian manufacturers who make both the same steel of functional properties at 0.6 kg also, 2.5 kgs also, right? And the problem is the awareness. Nobody asks these questions. What is the carbon footprint of the product I use in my building? And it can go for anything. I was just peeking into some of the charts that you folks have made. I saw someone writing down the aluminium's process, the life cycle process. Someone else drew the food food waste recycling process. So like that, for each process there is an emission, and the process emission of your products, raw materials that goes into the building is your embodied carbon. And it also has multiple other aspects. Even after your building is demolished, the processing of that waste will also be accounted in the embodied carbon. So basically, to simplify this, thinking about the life cycle of the building will give you these 4 broad stages. First is the product stage. You have the cement, steel, aluminum, glass, bricks, all of these materials manufactured at different locations. Then you have the construction stage. All these materials come to the site, and construction of the building happens, starting from the foundation till the superstructure, etc. Then the use stage. the life of the building can range anywhere between 30 to 60 years, depending on the design codes. And then the end of life of the building. Like after its serviceable years, it goes into either it is left abandoned or it is demolished and a new building is constructed. Okay, so these are the four stages of the building. So the second new jargon I am introducing is WBLCA, whole building life cycle assessment. Right, so whole building life cycle assessment is you consider the entire life cycle of a building, and you understand its emissions right from the raw material till the end of life, and sometimes beyond end of life of the building, which includes your reuse and also repair, etc. Okay, so broadly we could try to simplify that circular diagram into this. There's embodied carbon and then there's operational carbon, which put together gives the whole building carbon, right? And as you all might already know, there are multiple impact categories. Global warming potential is only one of them. Today for buildings, we are talking only the global warming potential, which is the carbon footprint. But ideally, we should look at multiple impact categories like acid rain potential, ozone depletion potential. But today's focus is going to be on embodied carbon and operational carbon, which is the GWP, right? Okay, so how big is this problem? When I say that this is going unaccounted for, this is a study that was done on multiple sectors. What are their contribution? You can see that buildings and construction is contributing to 32%. This is as per that study. And if we don't take any action on embodied carbon, the graphs are going to be stacked up like this, right? So you can see on the left side there is a 76-24. 76 is the operational and 24 is the embodied carbon. If we don't take any action in reducing this 24%, the stack is going to be like this. By 2050, it will become a 49-51. It will be as big as the operational carbon. Any guesses why this shift is happening? Why is 76-24 becoming 51-49?
The material usage.
Yes, the material usage is going to increase, yes. But why did 76 become 51?
The type of material. Maybe we will be adding renewable energy.
Renewable energy, energy efficiency, passive and active strategies to reduce the energy. So the technology, once you build the building, you can upgrade the HVAC, you can shift the energy to cleaner sources, etc. But you cannot change what cement was used, what steel was used. It's going to be there till the life of the building. So if we don't take decisions at the drawing board today, the buildings of 2050, 2060 are going to stack up like that, right? So that's why the awareness creation needs to happen today, right? So that's one area that I strongly focus on to make the decision makers. Who are the decision makers? The architects, the real estate developers, the building material manufacturers, that this is a problem, boss, you need to work on this. And the numbers I showed on the left side are global data. There is one more problem we have. We don't have enough data on what is the carbon footprint of our buildings, right? So this estimate says 60-40 is the number in India, right? So this study was done by IEEE and they are saying 60-40 is the number today in India and we have no clue how much it is going to be in 2050, right? So this is the problem that we have and the estimates are saying it's going to be 4x. So in 2020, whatever number was there, it's going to become 4x by 2070 and that's when we plan to be net zero, right, as a country. So this is the problem we have in hand. Let's look at how do we manage this. To manage anything, we need to start measuring it. So what gets measured gets managed is a very famous management quote and I'm applying it here for embodied carbon as well. And what are the existing frameworks? In India, we don't have our own framework for doing this, but there are global standards and guidelines available. 15978, the European nations, they have this standard which says how to report the carbon footprint of a building across its life cycle. So like how you have a standard for concrete, for steel, for manufacturing, this is only for reporting, calculating and reporting the life cycle impact of a building. And if you look at it from a product lens, it's 15804. Right, the environmental product declaration. The environmental product declaration in simple words is a mark sheet of your product from an impact point of view. So usually for us, we need to get more marks to be a good student. but in this case it should get less marks to be a good product. So lesser the impact, better the product, right? So the environmental product declaration, we have 15804. Then we have the EPD standard, which is 14025, and they give you the the standard way to report a EPD and publish an EPD. And 14040 is the the LCA principles. So we already have these frameworks in place which can guide us with the measurement. Okay, and I'm bringing you some new nomenclature as per 15978, which calls the product stage as A1 to A3. So this is basically whatever you have as the life cycle stages. They have given some standard ways of labeling them so that you have an apple to apple comparison between two buildings, right? So if I say that building A has 500 kgs per square meter carbon footprint, building B has only 250 kgs per square meter carbon footprint, the first question you should ask is what is the boundary? Are you only talking about the product stage, or are you talking about the entire life cycle, right? So these are some questions that you need to ask. So to reduce all those conversations, they have standardized all these formats. So A1 to A3 is product stage, A4 and A5 is construction stage, B1 to B7 is use stage, end of life stage is C1 to C4, and beyond end of life, EOL is end of life, beyond end of life is D. So A, B, C, D, product and construction are in A, use is in B, end of life is in C, and beyond end of life is in D. So this is the standard nomenclature that they follow. And just to put it up in one slide, this is how it looks. So A1 is nothing but the raw material supply. Say let's take for example cement. The cement raw materials include your limestone, and that's the basic raw material that you need, right? So where is the limestone coming from? That's the first question. The energy spent in mining that, the energy spent in processing that, all that will be in A1. A2 is transporting the raw material to the site, right? So if you are transporting that limestone from say Tada to Chennai, that has a 120 kilometer commute, right? So if you are commuting through diesel, if you are bringing it through EVs or petrol or CNG, all that will affect your A2. A3 is your manufacturing. So you are manufacturing cement. For that you will expend energy. So that will be accounted in A3. So A1 to A3 is your cradle to gate. So these are the standard boundary conditions defined in 14040. The cradle to gate emissions is A1 to A3, which is nothing but the cement manufactured, the carbon footprint which we discussed, 0.8 kgs, 1 kgs, all that is a cradle to gate, right? Then A4 is you get cement, you transport that manufactured good to the site, right? So that is A4, and A5 is a construction related emission. Now I have done this only for cement for all of you. Imagine steel manufactured in Jamshedpur, it is traveling to Chennai for a building. Then glass manufactured in Sriperumbudur is coming to Chennai for a building, right? So each material has its own loops. The line you need to follow the what is the cradle to gate methodology for each product, and that emission needs to be accounted for. So that is A1 to A3. Then you also need to have data on the transportation distances, right? So that's why the local procurement angle comes in terms of reducing A4 emissions of the building's life cycle. So now I'm just speaking this language. Now the construction equipment, if your construction equipment is using diesel, again you are going to emit 2.6, 2.7 kgs for every liter of diesel that is burnt, right? So that amount of emission needs to be accounted in A5, right? If their equipment is more cleaner equipment, if it emits lesser compared to compared to your diesel or other equipment, then that will reduce the A5 emission. So this is broadly A1 to A5. In India, A1 to A3 and A1 to A4 is what we have enough data for. A5 emissions is still a challenge because what happens in the site is in the control of the contractor. B1 to B7 is the use stage. Again, you can see multiple subcategorization. B1 means use, B2 is maintenance, B3 is repair, B4 is replacement, B5 is refurbishment, and then B6 is operational energy, and B7 is operational water. So usually B1 to B5 is what is accounted in the embodied carbon. B6 and B7 is your operational carbon. So the previous slide where I said embodied plus operational is the whole building, operational carbon you'll get it from B6 and B7. Then comes the end of life. So imagine that the building has served 30 years, 60 years, or how many ever years it is, and then the building gets demolished. For the demolition, you would use some equipment, right? That will consume some fuel, have some emissions. That will be accounted in C1. C2 is transporting that rubble to a processing center. C3 is the emission in the processing center, and C4 is going to be the disposal. So this is broadly, just the nomenclature given for different steps in the life cycle of that entire building. And anything beyond this that is not captured here will go into D, right? So this is broadly the life cycle of a building labeled as per 1597. You open any environmental product declaration of steel, glass, any building material, it will follow this, because the product category rule for an EPD for building material is usually following 15804. 15804 is an EN standard which was developed based upon 1597. Right? So the names and the labeling will be very similar. So everything in the built environment will speak the same language, right? Okay, so how big is each of this? This is a study done by I think KPMG for more than 400 or 500 different buildings, and what came out is A1 to A3 is contributing 56%, right? A4 and A5 is only 3%. This is for that particular set of buildings, right? This is for benchmarking. B1 to B5, you can see that B6 and B7 are not there because this study was focused only on embodied carbon. That is coming to 32%. And then C1 to C4 is 6%. And beyond end of life, we don't have data. So this is how broadly the embodied carbon footprint is distributed and how big each of these elements are. So clearly, if you are focusing on the product stage and during the the construction stage, we have access to almost 60% of the embodied carbon. You have control over 60% of embodied carbon across its life. The remaining 38 to 40%, there's only so much that can be done. For instance, you have I'll take the example of paint, right? Paint is something that will be repainted after a few years because it will lose its properties, right? It won't look as good. The paint done today, it might not look as good after 5 years or 6 years. So in that case, what happens? We do a repainting. We will account that in the use phase. Imagine a manufacturer is coming up with an innovation where you don't have to repaint it once in 5 years. Instead, you just repaint it once in 10 years or 15 years. Then which emission is going down? B1 to B5. The use phase emission, which includes the replacement, refurbishment, all that will be there. So product innovation through this lens is also another opportunity. I just gave you one example for that, right? Is this slide clear? Any questions on this? Right. So that's why the product. Yes, ma'am. Please.
Suppose if you want to measure a new building,
Yeah.
starting from the construction.
Yeah.
So how is there any protocol to measure?
So currently, it all depends on the foreground and the background data. For when it comes to buildings, the foreground data is quite easy to get because you have bill of quantities which are very detailed, and our folks are very detail oriented when it comes to the cost. The only problem is with respect to the carbon footprint, which will come from the background data. The background data will be mostly your environmental product declarations. I have that. I will show you where to get those data. So the data availability is one of the concerns. To answer your question, the bill of quantity is available, but the background data of how much is the carbon footprint of each material, that is a question. Then forecasting it across the life cycle, because each product will have its own different life cycle. If it's a paint, they have to consider the repainting into its life cycle assessment. So the scope or the boundary of each product is different. So all these challenges are there. So I get where you are coming from. It's difficult to project and find out. There is no protocol that is saying that this is how you should project it. But there are some methodologies with practice that people are following. Like they do account for some of these aspects when they do the calculation. In the absence of data, what we could do is we could take references, secondary references from research papers and stuff like that. But unfortunately, nobody has time to do all of that. That is the scenario today. No. I'm saying when you are repainting, it will be accounted. You will have to account for it. So, for instance, a paint itself has 1 kg of carbon emission, for manufacturing. For that particular manufacturing emission will be accounted in A1 to A3 only. So if for the new paint that is coming, that will be accounted in the B use phase. It will be there for the first time. If you are going to do a repainting etc. from for beyond its life cycle, that will be accounted there. So that's why in the EPD you will find it. A1 to A3 is this much, B5 is this much, you will be able to get it in the EPD. So that's why the boundary condition is very important. If it is cradle to gate, only A1 to A3 will be there. In that case, what will you do? For B5 you won't have data only. So then in that case you should look for another EPD which has A1 to A5, then up to C1 to C4 you have to find everything. Then B1 to B5 also will be covered. You can take that data as a reference data. You can't use it because in India everybody speaks A1 to A3. Beyond the gate nobody has control of what happens to that product. So that is the scenario. Even in many global products you will see this. Only A1 to A3 data will be available. Very rarely you will find cradle to grave data. Okay, fine. So some quick math. There are two things that you need to understand, that as I already explained, the material quantity is important. What is the material quantity used in the building, and what is the GWP per that material quantity. So in both the cases there are challenges of data. The first case is material quantity is something will be there in the bill of quantities, something will be there in the site. So that is one challenge. Second, the GWP, mostly the numbers available are European numbers. The Indian product manufacturers having their own EPDs and LCAs done, the number is less. So these are the two challenges in this slide. Then for any activity, so that is a material footprint, right? So that is quite easy and straightforward to calculate. 100 kgs of cement, 1 kg of carbon per kg of cement. So 100 into 1 is 100 kg of carbon footprint for that one line item. Do the same exercise for steel, aluminium, glass, concrete. You will find the carbon footprint for the entire BOQ. That is A1 to A3. A4, activities like A4, activity in the sense transporting product from site to the manufacturing site to your project site, that will need activity data. How much kilometers traveled, what is the type of vehicle used, what is the type of fuel used, all that will be required for calculating numbers like A4, A5, B6, etc., which are activity data, right? So just giving some example, A1 to A3 I just mentioned, 1 kg I am taking for OPC, ordinary Portland cement, 10 tons of cement used, which means 10,000 kgs of cement is being used, into 1 kg carbon dioxide equivalent per kg of cement is 10,000 kg CO2. This is for this one line item. Same for clear glass. If a regular clear glass 6 mm, so you can notice that when it comes to glass, the thickness aspect also comes in. 6 mm glass, 8 mm glass, 10 mm glass, and then how much area, like is it 10,000 square meter, 8,000 square meter. That's where the aspect of functional unit is very important. You need to, when you read the environmental product declaration, you need to note down what is the functional unit. It can be kg, ton, square meter. If it is a paint, it can be square meter painted, right? So all these are some examples. So it's a very straightforward calculation. Distance traveled can also have an impact, and also the capacity of the vehicle can have an impact, right? So if the capacity of vehicle is only 20 tons, your requirement is say 100 tons, so then you need 5 trucks. If you have a higher capacity vehicle, maybe it might emit slightly more than the regular vehicle, but maybe the number of trips will be lesser. So you need to calculate the number of trips, quantity. So it's a very, very straightforward calculation. The challenge is data availability, right? And this is how a typical calculation will look like for A1 to A4. I'm not sure if you could read it. What is there is aggregate. Then you will have aluminium, different areas where aluminium is being used. Then anti-termite material, asphalt, bitumen, AAC block. These are all different line items from the BOQ. Then in one column, you will be seeing what materials, what is the quantity of materials used. Then you can have your own classification, internal classification, like whether it's a virgin material or is a recycled material or it is a customized material. So that is for your internal understanding. Then you can also do it, in superstructure, substructure, whether it was used in a particular structural element like beams, columns, etc. That is also possible. So all that you do, and then you take one important column, which is the embodied carbon coefficient, which is nothing but the GWP of that product from the EPD, right? So that is there in red. So you multiply this with this, you get the embodied carbon emission. Then you can notice the next column, the transport medium, whether it is road or by sea, etc., as mentioned over there. And then the distance traveled by that material. And then for each type of travel mode of transport, you need to have a representative embodied carbon for that. For that, you will need to either refer to some sources which include the International Maritime Organization, the IMOs have their own databases, right? Or if it is going to be by flight, there are some CORSIA databases available. Mostly the IPCC database will also give you these numbers for the transportation, but if you need more data, you can find other databases and mention them in your calculations, right? So the transportation related detail is like how you do a GHG accounting. It's very similar, but the material level data you need to get it from EPDs. Okay, but where can I find this carbon footprint of this building materials? I think I slightly gave away that answer. It's from the environmental product declarations, or if it's in the absence of EPDs, that's the most reliable source of information. In the absence of that, you get some industry reports. Like for instance, for cement, there is something called the GCCA, right? So the GCCA is the Global Cement and Concrete Association. They release industry reports where you could get these numbers. Like OPC is 1 kg, PSC, which is Portland cement, that is so much kgs, and slag cement is so much kgs. So all that details you can get from industry reports as well. There are research papers available. There are institutes like LCA who also release some papers, methodologies, etc. Right? There's something called the CLF, the Carbon Leadership Forum. Right? So Carbon Leadership Forum is another source for a lot of case studies on embodied carbon. Okay, this is how a typical EPD will look like. I'm going to show you the anatomy of an EPD. If you open an EPD, you will have the brand name, the product name, then all these details about the product in the first page. You will also find the validity and the geographical scope. It's very site specific, because same glass or cement made in India, if it is going to be made in another geographical location like Europe or UK, it might have different energy coefficients, different sources of energy, distance of transportation. EPDs are always site specific. So if someone is giving you cement and they are giving you the EPD from Europe, cement from India and EPD from Europe, don't use that. It's not the right number, right? And usually the validity is for 5 years. Every 5 years we need to renew a EPD. Then the manufacturer details, the PCR. PCR is product category rule. And then you have a publisher and program details. So all these EPDs will be hosted in one publisher's website, like Environdec, EPD Hub, EPD Nord, etc. So these guys, they host EPDs and publish EPDs in their website. These are openly available. You can go and download them. Okay, then you will find the functional unit. In this case, it's 1 square meter of glazing. Then you will find the system boundaries like A1 to A3, cradle to gate, etc. from there. Then you will have the LCA results for that functional unit. For the mentioned system boundary, you will find it. So the GWP or embodied carbon, you will find it as how much kgs in either in the climate change section or in the GWP section. So some questions that you can ask, because every stage matters. In the product stage, how can I reduce the material consumption is a great question. Are there alternative technologies which can reduce consumption of concrete, cement, mainly cement and steel? That can be, if we can adopt that, yes, that can reduce the embodied carbon. Second, if you could not optimize the material consumption, because I'm just playing with that equation, material quantity multiplied by the embodied carbon is the total emission of that particular line item. So the first lever I am pulling is the material consumption. The second lever I can pull is the product. Does it have a lower carbon footprint? Is there an alternative with a lower carbon footprint? So that is the second lever I can pull. And always when you buy products along with your BOQs, this is something I want to bring in. If you are asking for a product, ask its footprint, right? It's going to take time, but we need to start moving towards the direction. Then the construction stage, can we procure locally available materials, because A4 is getting reduced, right? Then can we opt for lower emission transportation? If the distance cannot be reduced, can we shift the fuel from diesel to CNG, right? So that is the question. That's another lever to pull. Then can we use efficient and eco-friendly construction techniques? When I say eco-friendly, can the construction happen in a way that it consumes less energy, less water, less fuel, etc. So all that is the A4 and A5 emission. Then comes the B1 to B7. Can we look for materials that are durable? When I say durable, if it could last longer, then the replacement time like 5 years, 10 years can be reduced, right? So you don't have a new emission when you get a new product, like she was asking. Then can we choose materials that can make the building energy efficient? Like for instance, glass. You buy clear glass, it consumes higher, it lets in more heat, you need more energy to cool down the building. Whereas if there's a slightly better product like a coated glass, it lets in lesser heat, so the time taken to cool down is lesser. So if you look at from a clear glass to a coated glass, the emission goes from 20 kgs to only 22 kgs by doing that thin coating. But across the years, across the 60 years, it would have saved some energy consumed, right? So the operational versus the embodied payback is higher, right? So that is something that you can look for. But how will you know all this? You need to understand what is the embodied carbon A1 to A3 of that product and how much potential savings in electricity that it can bring in by opting that. Then how can we reduce the water requirement? Of course, today there are, I was there at an event where one of the cement manufacturers has a low curing product, plaster product, and there is a zero curing plaster product. So these are all there in the market where you don't need water for curing, right? So that's something that we could explore. Are the building components designed for deconstruction? So this is a big topic which also touches slightly upon what he was asking. Like what about the reuse? What about the, some components, if we could at the design stage define that this needs to be dismantled like this needs to be serviced like this is how you dispose these materials, that documentation can help. How do we take measures to ensure that there is clarity on how the demolition waste is managed? This is a big topic. There are a lot of regulations that are coming around this. What percentage of the building materials can be recycled or repurposed? How can we reduce the C&D? So this is broadly some questions at the early stage people can ask, right? If we find the answer for these questions, I'm sure that the embodied carbon reduction is also possible. So this is something I wanted to discuss. Okay. Quickly, let me take you through some trends that I observe. LCA is getting its way in green building certifications finally. For a long time, the green building movement in India was talking more about energy efficiency, water efficiency, because they were the problems that we were having. Now you can see LCA getting its place in green building certifications like IGBC, Griha, LEED V5. LEED has a recent one, LEED V5, etc. LCA also has its place in ESG frameworks like BRSR. BRSR is the Indian ESG framework called Business Responsibility and Sustainability Reporting. So they ask when this is mandated for the top 1,000 listed companies in India, right? So when they disclose their financial information, these listed companies also disclose their ESG performance as a report, and in that some criterias are linked to LCA. Then LCA is getting into regulations. So this I've seen in UK, I've also seen in Europe. I will share some examples, but there are going to be some regulations around life cycle assessment. So let's quickly see. So one of them is the ECSBC. How many of you know what is ECSBC? I'll go back. Okay, one of you.
It was earlier ECBC.
Yes, perfect. So it was Energy Conservation and Building Code, which is an Indian guideline in 2007 till 17 till 2024. It was a guideline, and 2024 onwards we have it as the ECSBC. And as per the revised Energy Conservation Act in India, buildings beyond a certain threshold should follow this. It's no more a guideline, right? So it's been getting mandated in phases, and in that you can find a chapter on sustainable materials which speaks the language that we just spoke, right? So EN 15978 is referred. kgCO2 equivalent per square meter needs to be reported, right? So that's one of the things that is there in ECSBC. It would have been even slowly there will also be some thresholds that will be released, right? So first it starts with measurement, and slowly you will also see some thresholds saying it needs to be limited to say 500 kg, 600 kgs per square meter. Things will be rolling out soon on all these topics. Okay, and then in green building rating systems, there's this IGBC's pilot rating system on net zero carbon buildings. IGBC has some 32 different rating systems 4 of them are net zero ratings: net zero energy, net zero water, net zero waste. The fourth one is net zero carbon. I was there in the technical committee while formulating this. They have set a threshold of 700 kgs per square meter, and against the 700 kgs per square meter of built area, which is including the A1 to A4, so which is the product and the transportation. So you need to buy a good product and buy it locally to make the carbon footprint lesser. If it has to go below 700 kgs per square meter, and based on how much percentage you reduce, you get points, right? So that's how this rating was designed, and A1 to A4 is a boundary condition for IGBC net zero carbon rating. So this is just some screenshot from the rating system. It's still in pilot mode, and they have two levels: net zero carbon and near net zero carbon. If you score 40 points, you get near net zero carbon. If you get 60 points, you get net zero carbon. And they have criteria on how to achieve each of this. And also in the new construction rating system itself, there are some revisions coming in. I have seen the draft. All I can comment is embodied carbon is also getting some this thing in it. It was launched in the Green Building Congress recently.
Everyone will have to start declaring.
Measuring and declaring it, right? So this is, and that is given as a credit. So if you go through the new rating system, you'll understand that this has got its place as well, right? I don't want to comment on it because I'm not sure if the final one is published or not, right? I was there in the committee, so yeah. Coming to this, this is from LEED V5. The recent one, LEED, is from USGBC. So I'm using all 4-letter abbreviations. These are all different rating systems. IGBC is the Indian Green Building Council. ECSBC is the Energy Conservation and Sustainability Building Code from the Bureau of Energy Efficiency in India. Then this whole building life cycle assessment credits, there is a credit and there is a prerequisite in LEED. LEED is from the US Green Building Council, because I also noticed that there are international delegates here. So LEED is a global rating system, and there even A1 to A3 is mandated. If you need a platinum rating, you can't get a platinum rating rated building by using bad materials, right? So you need to calculate the carbon footprint of that from A1 to A3, and for credits you need to do other other impact categories as well. There are some 6 impact categories defined in the credit, and if you reduce 20% compared to the baseline, you get some additional points. So that's how the credits are restructured now in the building material section of green buildings. So I'm just showing you what's happening in all these areas. So I'm not telling you that this is exactly what you need to do to reduce it, because this is an ever evolving topic, right? So you can see here, this is a mandatory requirement is MRP2. You can find it, it's from A1 to A3 is the coverage. So now you can go and see in different rating systems, if they are saying A1 to A3, it means cradle to gate, just for your understanding, right? So this is the thing I said. If you reduce it by 20%, if you observe the last line, for a platinum, LEED platinum is the highest rating in that system. If you want to achieve a LEED platinum, you should show that you have reduced at least 20% of the carbon footprint impact compared to a regular building, right? Without that, you can't get. Okay, Griha is another Indian rating system. The latest one is Griha V6. I'm still showing you the Griha V19 because V6 is still, I'm not sure if it is finally out there or not. But V19, there were 3 criteria. I checked the V6 document, these 3 criteria are still there. What they are saying is how you will use sustainable materials, sustainable building materials to reduce the embodied carbon. How they are incentivizing us: if you have a 10 to 15% reduction, you get 1 point. If you get a 15 to 30% reduction, you get 2 points. If you reduce more than 30%, you get 3 points. So all this is defined in the Griha rating system. You will also find it in the V6 rating that was recently launched. I think it was a month back. Yeah, so this is the scope in Griha. You notice that in IGBC it was A1 to A4, which included the transportation. In LEED it was A1 to A3 for the mandatory requirement. And then in Griha it is A1 to A4 plus B4. Reason is, the paint example I took. If you are going to replace it, then you are going to account for it, right? So this is giving credit for a durable material. If the material is durable, then the replacement emission will not come in its lifetime. right? So that is something that is different in Griha. Yeah, now the question will be what compared to what they will reduce by 10%. So they have also defined some base materials, right? So this is how the base case building will have to be built. Compared to the base case, you have to show improvement of so much percentage, right? So all this definition is there in the Griha standard. Okay, there is another rating system called EDGE. EDGE is excellence in design for greater efficiencies. The EDGE is coming from the International Finance Corporation. It's another international rating system, not India specific. And they have tried to simplify and make the rating system work on number basis. When I say number basis, they already have the database of the baseline energy, water, embodied carbon numbers. Compared to that, if you show that your building is 20% energy efficient, 20% water efficient and 20% lesser embodied carbon, you get certified. So they have simplified the entire rating system and you can see dashboards on their tool. This is an openly available software where people can go and model a few things. Say that my home is say a 2000 square foot building. Compared to the base case, if I replace few things, instead of a clear glass, I use a better glass. Instead of a regular cement, I use a different cement. All these initiatives, you just check the tick box and you enter some basic information. It will tell you how much percentage lesser are you compared to the base case. So this is something I would recommend all of you to go and check. And embodied carbon is one of the 3 pillars of what they are measuring to give the certification. How much time we have? I'll take another 10 minutes. Yeah. Then this is about the ESG, LCA integrated in BRSR, the business responsibility and sustainability reporting. Principle 6 is for the environmental impact, and in principle 6 you will find mention of how are you understanding the life cycle impact of your product, right? So that needs to be declared in the BRSR report of these companies. So this is a good trend to observe that SEBI launched it 2 years back. SEBI is the the regulator for all these stock exchanges. So they mentioned that top 1000 companies should declare all of this, and we have got 2 years of reports already available, published, right, for all these 1000 companies. Okay, so there is another ESG rating called GRESB. GRESB is Global Real Estate Sustainability Benchmark. There also they are speaking about how you can reduce the embodied carbon of the building. What measures are developers taking to reduce the embodied carbon of the building? For that also there are some point allocations. So you could look up GRESB and what is it. It's like, to simplify, it is a benchmarking. They will give you a benchmark number. Say for example, developer A is at 100 points, developer B is at 85 point. An investor who wants to put their money in that real estate company will understand compared to developer A, developer B is better based on the score that they get. So they have got a framework to give points if you have good policies, green buildings in your portfolio, and then embodied carbon measures, then your occupant comfort. Like how for a building you have these green building rating system, GRESB is for the entire portfolio or for the company. So this is a corporate sustainability rating system, and you get a score, and in that also you have few areas where LCA and embodied carbon is getting its place. Right. Yeah, so in CDP is Carbon Disclosure Project. So they also give some ratings like A+, B- for companies. This is again at the company level. There also you can find life cycle assessment getting its place and mention, right, directly or indirectly, as either a scope 3 emission or emission reduction initiatives or low carbon investments. Especially for real estate companies, the low carbon investment will be embodied carbon reduction mostly, right? Okay, now some more trends that we observe in EU. There are some regulations that are coming in place, like for instance the ESPR, which is the Eco Design and Sustainable Product Regulation. So there you can see it's not only for construction, for multiple product categories they are developing product sustainability regulations. So this can be a trend that can also happen in the Asian countries and other developing countries. And yeah, there is a small video, but I'm not sure if we have time. In the absence of time, I will send across the video. It explains what is ESPR and what products are covered, etc. So I will share that with the faculty, they will share it with you, right? But do look up ESPR. So it's a 1-minute video. So you can see for it's covering many product categories, your mobile, your electronics, your textiles, all of these are covered in it. Construction products are also part of it, right? So sustainable design requirements for different products. The audio is not there, but I'll send across the video to you. Okay, so then there is something called the DPP, which is the digital product passport. Like how we all have a passport when we travel to a different country. Imagine a product having a passport which says where was it made, how was it manufactured, what was the environmental impact of that product. This has already got an implication in the textile industry. So DPPs are going to be implemented soon in the Europe, and if you are exporting to Europe from your country, this is something that you need to look up to. And the core basics of this is an LCA. Only if you do an LCA, you can report it in a format which is like a DPP. So you make it into a PDF and publish as per a standard and put it in a publisher's place, it is an EPD. If you are going to make it into a DPP mode, it's a more digital passport. And when I say digital passport, there is a blockchain angle to it. So this is again another study done by Deloitte. They are saying what are all the opportunities in DPP and what are the technologies that are there in DPP. So there's going to be blockchain, there's going to be private blockchain, public blockchain DPPs. So in the Europe. Then product registries are another trend from the European Commission. You can see multiple product categories. All those small on the left image are all different products, and you can label around each of these product category. Plus, B plus, there will be a green color, red color label for each product category, and they would have defined how to of this product registry. So this information will be, someone wants to get into a green procurement, this will be a very good database for them to include it, right? So this is another trend that I wanted to highlight. So broadly, in 1 hour, what is embodied carbon? So jargons I try to simplify. Stage, then A1 to A5 is stage. So we have discussed we need foreground and background data that help us in making more accurate calculations. Coming nationally, internationally, getting its place in ESG ratings, because if you look at it, there's a business angle to it. Investor, what is your ESG performance, and life cycle ESG performance. So in a way, if you're looking at the data or you're not having a life cycle thinking, it's going to affect your revenue, it's going to affect your investment, your brand. So these are all the business angles which will going to right. So I'm sure that you are in more capable hands to explain how to do the LCA and what is to be done, etc. So I wanted to make sure that I bring the industry angle to it and what's happening there in businesses. So that's about it. And I also have this academy, do check it out. Every week I send a micro learning course and things like that. So I don't want to promote it here, but just wanted to let you know that this is also there for you to learn. And I will leave you with that quote, climate change is not slowing down, neither should be. So let's upskill ourselves and act on it. So for more information, you can reach out to info@climatecto.com. Thank you so much.